Hey guys, welcome back. Today we're solving the problem sum root to leaf numbers. We're given the root of a binary tree, and this binary tree contains digits running from 0 to 9 only. Our task is to find the sum of the root to leaf numbers. Like in this case, we have this leaf node 5, and we have a path running from the root all through to the node ending at 5, like I have highlighted. We also have another path running from 1 all through to the root and down to 1, like I have highlighted in blue. And finally, we have the third path running from the root all through to 0. This is the shortest path that we have in this entire binary tree. If we consider the first path from the root to the node ending at 5, we can take all the integer values here and sum them up. If we do take all the integers running from the root all the way to the node ending at 5, we will get 495. Our task is to sum all these integers from the root to all the leaf nodes in this tree and get the actual sum. So the first values are 4, 9, and 5. We can take this, add it to 491. 491 can be obtained from the root, taking through this path all the way to the leaf node. We can do the same for the last path, that is 40. Once we add the path from the root all through to the end node at 40, we'll get a total sum of 1026. This is how we'll be computing the sum from the root, the actual root here, to the leaf nodes. The leaf nodes were 0, 1, and 5. But now you'll realize that we'll be adding these values, the integer values, along the path of one of the leaf nodes, and we'll be doing this recursively for all the leaf nodes that this tree has. So how can we approach this? The first thing you need to note is that the value of the root node will always be the first value we will take, and we will do this recursively using a pre-order traversal of a binary tree. So we'll process the first node, the root node, and then go to its left child, and we'll try to do this until we reach the first leaf node to the left before going to the right. So if we do this, we will take the 4 here, and then we'll go to its direct left child, and it is a 9. So how do we add this 9 to this 4? We want to add this 9 to the right of this 4. How can we do so? We will maintain a value called a path sum, and by default, this will be 0 as we start from the root. What we will be doing with this path sum is that for every single level that we traverse in this tree, we'll be multiplying it by 10 before we add the value that we want to check. So by default, it will be 0. So 0 will represent the first layer in this binary tree. When we reach this layer of this binary tree, we will take whatever the path sum will be, multiply by 10, and add the root node at that given level. We will start by 0, and when we reach to this node with a value 9, we'll take the path sum, multiply it by 10, and add the value 4 to it. So that will represent our layer at this given point. We will also take the 9, and we will try to see, does it have a left child, and we will traverse its entire left side of the tree. So when we go to this level, when we approach the node with the value 5, again, we'll take whatever the path sum will be. So in this case, it will be 4, because this will just equal to 4. We'll take whatever value the path sum is, multiply it by 10 again, and then add this 5. So when we do this, the math will look like this. So when we compute these values, you can see we'll be multiplying by 10 before adding the value that we are visiting. So at this given position with the value 5, we'll take whatever we had, 49, multiply by 10. That will give us a 490, and then we can add the 5. Now, when we add this 5, it will just be added to this right hand side of the 0. So it will be added to the 0, and that will give us 495. And you can see if we take all the integer values from the root of this tree down through this path up to the leaf with a node of 5, it will just be 495. We'll repeat the same process for all the other nodes, the node at this point and the node at this point. And that is how we'll be achieving the 1026 value path sum that we had. So this path, this other path, and this path. The total of these three paths will result in 1026. Now let's code this. Like I said, we'll be doing this recursively, and I like to define a nested function to help me with this. So it's pretty simple. It's a DFS search that we're traversing within this entire binary tree. So I'll just define a DFS function here, and our function will just take the node that we are currently visiting and the actual path sum up to this given point. First base case we need to check is if the node is null, and if that's the case, we can simply return 0 because there's no value here. Now remember, we've said that we want to add the value at this given node to the path sum. But before we do so, we need to multiply this path sum by 10. So we can just say that path sum will be multiplied by 10, and we'll save the result into the path sum. And now we can just add to this path sum the node.value. After this, we need to check, is this node a leaf node? Does it have the left and the right children? So if it doesn't have the left and the right children, we can just simply return the path sum. So we'll just check if not node.left and not node.right. In this case, we can just simply return the path sum. Otherwise, we'll do the recursive part of this function, and we'll just be calling the node.left, passing through the path sum as our current path. And we'll add to this the DFS, the node.right, with the path sum. Now, whatever this returns, we can simply return it as our value. And the only thing that remains is to call our DFS, and we'll just return whatever it returns. So the main node that we'll be passing to this DFS call is the root node, and the default value that we'll be passing as our path sum is 0, just like we discussed in the drawing. Now let's run this, and as you can see, it works and it's very efficient. If you enjoyed this session, please like and subscribe for more content just like this, and I'll see you in the next one.